from yesterday. Yesterday we covered, let me think what we covered. So we did proof strategies. So we did this. We did induction, simple induction. And I think we did sets as well. What else did we do? Let me see. Sets, contradiction, induction. Yeah. Okay. Today I want to do one field question. So today I want to do one field question. And I want to do image, because people don't understand image. And I want to talk about Cartesian product. And I want to do the function for bounded function. So bounded. And then we'll go back to AGM. Inequality. Is there any other topic you want me to go over? Let me see chat. Axioms in quiz 2, question 2. Okay, so we'll do quiz 2, question 2 as well. So that's part of the image question. Version 1. Okay. Any other topics you want me to go over? Oh, we might do some like combination of two different topics again. I think yesterday we've seen that kind of question. So we did contradiction with sets. We did contradiction with what else? We did contradiction with, I keep forgetting. Contradiction with sets. And there was a word question, contradiction question. Oh, induction with function. I didn't do it, but I left it for you. Did anyone do this? Yes, they can be. I know at least one of the prof in the teaching team likes that. So there might be, I don't know. I haven't seen your test yet, but there could be. So we'll do that, like combination of different things. We did combination. Yeah, I think that's it. Oh, and I did a combination of contradiction and contrapositive. So today I want to do a combination of contradiction and sets again. And I'll try to find other things we could have. But let me see. For now, we'll do that. Okay, so let's do the field question first, because I think it's a really good question. I mentioned yesterday as well. Let me find the question first. Okay, so here is a question. We have a field F be a subfield of R. So you would ask, what's that field? So the definition is, it's given, okay, so F is a subset of R as a field with respect to the UU addition and multiplication. Of numbers. Well, you know it's about numbers since it's a subset of real number. Suppose that square root of 2 is in a field. And square root of 3 is not in F. Okay, and we have two questions. The first question is asking, is 3 over square root of 2 minus 1 in the field? And explain. And the second part is asking, is square root of 6 in the field? And explain. Okay. As always, I'll give you some time to think about them, and then we'll take it up. Anyone has any idea of how to approach this question? First one is true. Okay, what about the second one? Second one is false. Okay, cool. Good. That's correct. This is yes. This is no. Explain why? Okay, let's see. 1 is enough, yes. So root 2 minus 1 is enough, okay? Square root of 2 must have multiplicative inverse, that's true. Are you saying square root of 2 minus 1 has a multiplicative inverse, or square root of 2 has a multiplicative inverse? Okay, cool. And what else do we do? So now we got 1 over square root of 2 minus 1. What about the 3? Okay, exactly. Because 3 equals to 1 plus 1 plus 1. Yes, exactly. So you guys got it. Okay, so let's write it down. Yes, we know that 1 is in the field. Okay, so by existence of negative, or by existence of additive inverse, we know that negative 1 is in the field as well. By closure, we know square root of 2 minus 1 is in the field, and 3, which equals to 1 plus 1 plus 1. Actually, let me write it the other way around. 1 plus 1 plus 1 equals to 3, which is also in the field. And since by reciprocal, we know that 1 over square root of 2 minus 1 exists. It's in the field. Okay? Therefore, and then by closure, we know that 3 times 1 over square root of 2 minus 1, which equals to 3 over square root of 2 minus 1 is in the field. Okay, so the whole thing is in the field. What about the second one? Why is it false? Why is it not in the field? I think that's not really a formal proof. Okay. It's more like a rough work. Anyone else? Yes, yes, you can do that, exactly. Okay, so what I'm gonna do is I'm gonna suppose square root of 6 is in the field. So for contradiction, suppose it is in the field. Okay, then we know that by closure, no, by inverse, by reciprocal, we know that 1 over square root of 2 is in the field. Okay, and by closure, we know that 1 over square root of 2 times square root of 6, which will give us square root of 3, is also in the field. So this is a contradiction. Therefore, square root of 6 is not in the field. All right. Any question regarding this question? Question? Okay, cool. Let's do, what did I say I'll do? Image question. Let's do an image question. And let's talk about image. Image. Let me find a question. Let's do, how do we prove Q is a subset of F? Q is a subset of this F, this specific F? Or are you talking about Q is a field? Like any subfield F? No, Q is not a subset of any F. You can have a finite field which does not include Q. Okay, let me find the image question first. When I try to find it, you should think about what is the definition of image, okay? Okay, let's say we have a function that f mapped from A to B defined by, we don't have anything. So this is just the f, okay? B A to B. So What is the image of the function? And the image of f is what? Think about this. Yes, it's also called the range. Range is like a name used in calculus. I think in every other proof course we call it image. Only calculus call it range. At least from what I see, I've never seen any non-calculus courses call it range. Okay, someone said f of a. Can you be more specific? What f of a equals to? It's a set. Let's write it in a set notation. Anyone? Yes, exactly. F of a, where a is an element of a. I want to talk about the definition because when I mark quiz 2, question 2, it seems like a lot of you don't really understand the definition. At least from that question, it looks like people don't really understand the definition. Okay, so basically, the image of the function is a collection of your output. In other words, you put every single element from your domain, sub that into your function. Whatever you get, and the collection of that is your image. I don't know if that makes sense. So for example, we have a set A. So example, we have a set A equals to 1, 2, 3. And we have B equals to 0 to infinity. Okay, and our f is defined by x squared. The image of f would be you sub every single element of a in this function. So f of 1 would be 1 squared, so that's 1. Oops, 1. F of 2 will be 2 squared, which is 4, and f of 3, which is 3 squared, which is 9. Okay, so that's the definition of image. Some of you asked me to talk about Cartesian product. So let's say, if you have a Cartesian product B, well, we have different A and B now, okay? Let's say our A is 1, 2, and B is 0, 2, 4. If you have a Cartesian product B, that's gonna be a set. So your X takes from here, takes from A, and your Y takes from B. It could be all the combination of those. So X takes from A, your X could be 1, your Y could be 0, X could be 1, Y could be 2, X is 1, Y could be 4, and X is 2, Y is 0, and such things. 2, 4. When a Cartesian product becomes your domain, so let's say our F map from example 1, 2, 3, map from integers cross integers. to an integer. Okay, so this is a function with Cartesian product being your domain. Then let's define a function. Let's use oops, now you have mn equals to, what function do we want to use? Let's say m squared plus n squared. Okay, now remember that if Cartesian product being in your domain, then the input you have is a pair of numbers. It's not just one x. You need to pick one from that and another one from that. So it's a pair of numbers. So in this case, your f will be something, you could have something like f of 0, 0. Remember 0 is an integer as well, okay? I saw a lot of people think 0 is not an integer. It is an integer. So that would be 0. You can have 0 f of 1, 2, which will give you 1 squared plus 2 squared, which equals to 5, and so on. Okay? And they may ask you, let's say something like this. Find an element from Z such that it's not in the image of F. Let's do this question. Okay, I just made it up. Let's see if you guys can do this. This is really similar to a quiz 2 question. Slightly harder. Actually, it's pretty easy. Just realized something. I made it too easy. But it's okay. Let's see. Okay, anyone got one? Yes, any negative. That's why it's too easy. That's why I said it's too easy. Any negative, okay? Because, well, this is apparently non-negative. This is greater than or equal to 0. So let's make some changes. Let's change it to negative. Change it to minus here. All right, and then this will give you 1 minus 4, which is negative 3. Now find another. Oh, you're confused? Okay, because for the first one, okay, so when we have m squared plus n squared, we know that this is non-negative. This is greater than or equal to 0. This is greater than or equal to 0 as well. So the whole thing is greater than or equal to 0. Does that make sense? So no matter what m and n you pick, the whole thing is always greater than or equal to 0. So if you pick any negative number, you can never reach that. Does that make sense? Okay, so that was too easy, so let's do a harder one. Okay, if you picked one, you need to tell me why it's not in the image, okay? Oh yeah, this is a great question. I like this question. This is a great question. Randomly made a great question. Exactly. Okay, so one of you said 12. So let me use another color. Great question. So when let's say 12 is in Z, but 12 is not, should we say 12 is not an element of f of Z cross Z? Why? Because suppose it is in there. Then we have m squared minus n squared equals to 12. Difference of square will give us m plus n, m minus n equals to 12. So this becomes a combination of image, combination of contradiction, and the show that an equation has no integer solution question. Okay, but what you said, you didn't discuss all cases. Actually, I don't know if it's true. Let's try. Because 12 has multiple divisors, we can have 3 times 4, 2 times 6, also negative, also negatives as well, because m and n are integers, not natural number. Okay, so we have a lot of different cases. Let's pick an easier one, because this is too complicated. Let's pick an easier one. Let's pick a prime number so that our life is easier. Let's pick 5. I don't know if it's gonna work, but let's pick 5. Actually, 5, yeah, whatever, 5. 7 will be a good one as well. So I'm gonna pick a prime number, because for prime number, they only have 2 divisors. So we have less cases to discuss. We know that 5 equals to 1 times 5, 5 times 1, negative 1 times negative 5, and negative 5 times negative 1. So now we have 4 different cases. Okay, you need to discuss all different cases. So you could have m plus n equals to 5, m minus n equals to 1, m plus n equals to 1, m minus n equals to 5. You can have m plus n equals to negative 1, negative 5, n minus n equals to -1, n plus n equals to -1, n plus n minus n equals to -5. So you have 4 different cases, and you solve for all of them. So this will give you, let's say, add them together, 2m equals to 6, so m equals to 3, and 3 plus 2. Oh, we don't have a contradiction. 5 doesn't work. Okay? 5 doesn't work, because we can have 3 too. Try another one. 5 doesn't work. Let's see. Which one is a good one? Let's try 7. Anyone found one already? I don't know if it works, because 12 we need to discuss too many cases. 7 does not satisfy? Okay, so we cannot try 7. Let me come up with one. M minus n. True. Would 1 work? Let's try 1. Okay, let's try 1. Because 1 is simple. 1, then we only have 2 cases. Then we have 1 and 1. It doesn't work. You can have 1 and 0. Because we have 0. Doesn't work. What I would do is I would compute some of them and see if there is anything. Actually, let me think. No, we just talked about 5 and 7. Those are primes, but they don't work. Okay. 4, then we have 2, 2, 1, 4. 4, let's try 4, 1. 2, 2, it doesn't work. 4 doesn't work. Okay. Because again, we can have 0. So if itself is a if the number you pick itself is a perfect square, then it doesn't work, because you can make the other one be 0. So it cannot be perfect square, and it cannot be difference of perfect square. So it cannot be perfect square or difference of perfect square. So perfect square, we have 0, 1, 4, 9, 16, 25, and so on, cannot be difference of them. So 1 minus 9, -7, so 7 doesn't work, 5 doesn't work, 3 doesn't work, 2 doesn't work, 1, 2, 3, 4, 5, 6. Anyone see if 6 works? Let's try 6. Wait, but 6 has too many numbers. 16. Let's try 19. I feel like 19 is a good number because I like 19 and it's a prime number. I feel like I made it too hard, but it's okay. Try 19, and someone tell me if 19 works, okay? Nineteen, 1, 20, so this is 10. Oh no, it doesn't work. Yeah, it doesn't work. I feel it might be, the image might be all, can it be all that? Actually, okay, times 2m equals to, as long as 2m is a even number, then it works. So we need those two add together be an odd number. Odd number, but we have 1. So we need this to be even. We need an even number. We need an even number. It doesn't work. Six doesn't work. Yeah, I feel like I picked something that the image might actually be all of that. 8. If this is 8, but 8 we could have 2, 2, 4. That's 6. That's even as well. Yeah, I think I picked. Why am I muted? I think I picked something that has it has image of all of that. This is a bad choice. Yeah, I just realized something, because if you pick even number, if you pick, yeah, I just realized something. If it's odd, okay, I don't know if you guys realize this. If the number we pick is odd, then it always work for this case. So it means all odd number is in the image. If we pick even, okay, if we pick even number, it's always divisible by 2. So it's gonna be 2 and another even number. They add together, it's still even. Over 2, it's still even. So all even number works as well. Which means the image of this is actually all the integers. Well, then let's change the question. Prove that the image of this function is all of z. Might be a little bit too hard. Anyway, I just show you why, actually. it's not a formal proof, but I showed you. Did I convince you it's all of integers? Did I convince you it works for all the integers? I didn't show you the real proof, but anyway, it's a bad question. Yeah, this will be too hard for you guys. Hopefully they don't give you something like this. But is there any question? Let me find an actual thing that works. How would 12 be in the range? Well, 12, you can have m plus n equals to 6, m minus n equals to 2. Then you add them together, that's 8. So m equals to 8, n equals to minus 2. Wait, is it? No, wait. Oh, equals to 4, sorry. M equals to 4, and n equals to 2. Yeah, that's how I realize everything works. Because in order for it to be not working, we need those two numbers add together be an odd number, so that one of them is not an integer. As long as it's like integer, then it always works. But the thing is, like, if the number we pick is odd, okay, let's say if the number we pick is prime, okay, if it's prime, then we only get this number times plus 1, because like all the primes except 2 are odd, so that means the add together is an even number. Over 2, that's always an integer. If it's even, it's divisible by 2, so 2 plus another even number will give you even as well. So over 2, it's still an integer. If it's other odd number, not prime, they can have other divisors, and other divisors, let me think. So such as 7, 9, such as 9. Okay, oh, 9 doesn't work. Such as 12. No, even, I want even number. 11, 12, 13, 14, 15. 15. Then, wait, does 15 works? Because I only consider prime. 15, 3, 5. Yeah, it doesn't work. 3 plus 5 is 8. Yeah, so that's even as well. So all the even numbers and odd numbers are actually in the range. Anyway, bad choice. Let me find an actual example. This is a bad choice. Image. I don't know how else they can give you an image question except for ask you to prove it. I'm not even sure if it's gonna ask you to prove it again. Oh, what about this one? This is a good one. F from natural to natural, natural cross natural to natural, and our f of AB equals to A times A plus 1 times B over 2. Prove the image of F is N. Try this. This is a good question. No. 0 is not a natural number. Would it be too hard? Yes, you can say that. Yes, you can say that. Because right now you only have addition and product, so it's gonna be okay. Let's see what you guys said. So you said a times a plus 1 times b will always be even, yeah? Okay, and so always divisible by 2, okay? And to get another n. Okay, so you show that the image of this function is a subset of natural number, okay? What about the other way around? So you guys showed the image of the function as always a subset of the natural number. So you need to show both ways, guys. You need to show f of natural is a subset of natural, and you also need to show natural is a subset of f n cross n. So what you guys did, you showed the first step. Let a b be elements of f n n, and you guys, what did you guys say? Since a plus 1 is even, actually need to explain this. Since a and a plus 1 are consecutive integers, a times a plus 1 must be even. So a plus 1, b must be even. Therefore, a plus 1 over b over 2 is an integer. Also, since a plus 1, b are greater than, strictly greater than 0. Let's just add over 2. A plus 1, B over 2 is in let me write f of, yeah, this is in natural number. Therefore, actually, I want to add something. Let this be this, the I don't want it to be AB. Sorry guys. We use something else. Just realized something. I made a mistake. Let Y be an element of this. Okay, not AB. Be an element of this. Then there exists AB in natural cross natural such that f of AB equals to Y. Now it's good. Now it's good for this proof. Okay. Now we have A, B, because the even, this is integer. Therefore, f of natural plus natural is an element, is a subset of natural. What about the other way around? Let's prove this. So let's let Y be an element of natural number. You want to show, what do we want to show? Why do we add Y? Because first of all, you want to, I needed to pick element from the image. Okay, so I'm just calling the image, each of the image Y. Not really adding anything, but Y equals to this is an element of that. Yeah. The other way around, if we let Y be an element of natural number, what do we want to show? We want to show Y is also an element of the image, which means we need to show there exists AB in natural cross natural such that f of AB equals to Y. Okay? How do we know? Because they are all natural numbers. A is greater than 0. A plus 1 is greater than 0. B is greater than 0. So 2 is greater than 0 as well. So the whole thing will be greater than 0. Does that make sense? Because here, because A plus 1, B are all natural number. Want to show, need to show. Want to show and need to show. So anyone got this? The other way around? basically we need to write a and b as expression of y, as function of y. Such that once you compute it, you can get back to y. Yeah, you can do that. But the thing is, even if okay, this is just try. If you do this, that's rough work, okay? This is rough work. If we do this, here you have two different variables. Here you only have one. What are you gonna do next? Okay, let's see. A squared b plus ab minus 2y equals 0. What do you do next? You need to show both a and b exists in natural number. Usually you only have one variable. That's why you can use quadratic formula. Now you have two variables. Well, in this case, again, now you have two variables. You need to show both a and b are natural numbers. Okay? You need to show both a and b are natural numbers. This is not even real number. Discriminant would work for real numbers. When you need to show it exists in real, you can use discriminant, but in this case, you cannot use discriminant. So this doesn't work. Anyone come up with something else? By case, what different cases do you wanna discuss? 2y is even. So you made it by. Okay. What cases do you want to discuss? Even and odd. I don't think it works. The reason is that you want to show we have a and b in natural number. Okay? So there is nothing to discuss, because if you discuss even and odd cases, you are assuming that they are integers at least, but now we don't know about that. You want to prove they are natural numbers. So you made the assumption that assume that they are natural numbers already. So you cannot do that. Now we only know y is a natural number. Okay? We know y is a natural number. Now you need to prove that a and b are natural numbers as well. So what I'm thinking is that let's look at this function. Okay, let's look at this. Note that, again, as you guys mentioned before, this is even. Okay, so over 2, that's gonna be an integer. This is even. Can we make this whole thing 2 such that over 2 it becomes b? You should know, as you can see, it's possible. Okay, so if a equals to 1, then 1 times 1 plus 1 times b over 2 will give us b. And we know b is natural number. So in that case, we know that, well, our B will be our Y. So let AB equals to 1 and Y. Since 1 and Y are both natural numbers, okay, so I show that I have A, B, both being natural number, and I want to show f of AB equals to Y. Would be A plus 1, B over 2, which will give us 1 plus 1, Y over 2, which will give us back Y. So in this case, now I show that Y is also an element of f of natural cross natural. Therefore, this is a subset of this. No, I didn't assume that to be true. So again, I want to show that I can find AB in this, such that f of AB equals to Y. Because I want to show Y is an image, is in the image, right? So for Y to be in the image, that means I can find element in your domain such that f of that is Y. So now I found my AB. Okay, I found my AB to be element of natural cross natural, such that my f of AB equals to Y. So I need to show this, and I found this already. So that's why I'm done. Yeah, we don't need any other case. You just need to find A and B such that f of AB equals to Y. That's all you need to do. Does that make sense? Yes, I picked AB to be 1, Y. And eventually I got back to Y. I think this could be a good test question, okay? Doesn't matter when A is not 1, because we found, yeah, I found it by rough work. I found it here. This is my rough work. It's short, but it's my rough work. It doesn't matter when A is not 1, because I showed that my Y is in the image already. So when my AB equals to this, my Y is in my image. As long as you find that, yes, because it's it. We need to show there exists AB. Need to show there exists AB in this such that this. Okay. Which means when A equals to 1, you can get any of the natural number. Any of the natural number you want. Any other question? Image. I spent so much time on image. We did image, we did field, we did image, we did Cartesian product, function. Okay, function. We have 40 minutes left. Let's do function. Bounded function. Bounded function. Bounded function. Do I have any question? found it was almost never being tested, but we will do one question. I will give you another question. I'm not gonna take it up because we don't have time. Just try it yourself, okay? Another good question. Extra practice. Extra practice. So, if the sum of n, which is a natural number, sum of n natural numbers is less than n plus 2, then each of these numbers is less than 3. And I want you to prove by contradiction. This is extra practice 1. Extra practice 2. So I'll give you a lot of questions for you to practice. Do we have another one? Show that if A union B equals to A intercept B equals to A, then A equals to B. Number 3, show that B is a subset of A if and only if A minus B union B equals to A. Oh, here is a good one. We'll do this one. We'll do this one together. This was too easy. What else? Do I have any other good questions? Oh, here's another one. It's another set question. Let's A, B, C be 3 sets. Prove that if B minus C is a subset of a complement, then A intercept B is a subset of C. And let me give you another one. I have so many set questions. Oh. Give you this. Number 5. Given two non-empty sets A and B, use contradiction to show that if A cross B union B cross A equals to A cross A, then A is a subset of B. That's it. That's everything. And I'll find, what did I say I'll do? Is there a solution? I don't have a solution. If you have any question, just discuss it in Discord, okay? Are you guys in Discord? The Discord server? Yeah, okay, cool. If you're not, let me send you the link. Yeah, just discuss it in Discord. Because I don't think I have time after 12. So I don't think I have time to write the solution either. Where is the link? Link. Let me post the link here. So if you're not in Discord, you can join. Just make sure you pick a row, okay? What did I say I'm gonna do next? Function bounded. Oh yeah, bounded function. And we'll do AGM. Quiz 2, question 2. Oh, quiz 2, question 2. Let me do that first. Quiz 2, question 2. It was function from that to that, that times that to that times that, and defined by f of m and, oh, I think they used xy, whatever. F of xy equals to x plus y, x minus y, right? Are you from my tutorial? If you are from my tutorial, yes. If you're from other TA's tutorial, I don't know. Okay. Yeah, because it depends on the TA. Problem set. I think he meant problem set. Yeah, I wish you can get your own pets tonight. That would be fun. You know, distribute pets to you guys. Like sign up for what kind of pet you want, and we'll give you a pet tonight. That'll be fun. Okay, so for this question, you want owl? I have one dog and one cat, and I want another hedgehog. But I don't think they'll get along, so that's a no for me. I wish I have another hedgehog. I don't have one because I feel like my dog and my cat would bully them if I have one. Yeah, I don't want that to happen, so anyone want to explain this question to the person who asked while I try to find the bounded question? Anyone? I think we have a bounded question. Do we? Not you? You don't want to explain? Oh, I found one. I found this. I don't know how to. Okay. So let me explain because I found the question already. So basically, the common mistake of this question is that people think since our x and y are both integers, so x plus y and x minus y would be integer as well. Therefore, the image of the function is all over that cross that. That's the common mistake. Okay, that's the common mistake. But the thing is, that only means that the image of the function is a subset of this. Remember, when you try to prove the image of a function is something, you need to prove both ways. So a lot of people, they only show, so they are thinking that, oh, this has to be an integer, this has to be an integer, so that will be all of the integer. So that's a common mistake. When I get the question, the first thing I was thinking is that, well, I have x plus y and x minus y. There must be something that's not in this. Why? Because if you think about this, the difference of those two numbers, okay, so the difference, so if you use x plus y minus x minus y, the difference of this is 2y. Okay, the difference of this is 2y, which means that if you pick two numbers such that the difference of them is not 2y, or in other words, it's 2y, we know it's even, this is even. So if you pick two numbers such that the difference of them is not even, then that's not going to be in the image of this. So there are a lot of you can pick. You can pick f of no, not f of, you can pick so the difference, we don't want it to be even, so you can pick 0 1, you can pick 1 2, you can pick 5 6, and so on. Okay, so if you pick any of this, you need to show me it's not in the image. So let's say we use this. Then x plus y equals to 0, x minus y equals to 1. This will give you x equals to 1 over 2, y equals to 1 over 2, negative 1 over 2, 1 over 2, negative 1 over 2. Because I want to say what's the difference between those two numbers. So like I want to find a relation between those two numbers such that I know that I know what to pick. So you can add them together as well. Let's say add them together. That's gonna give you 2x. So if the sum, well, you can think in that way as well. Add them together will give you 2x, which means if the sum is not even, then it's not from the image. Both works. So basically I was just trying to find the relation between those two numbers. Okay, so now I know, well, the difference has to be even and the sum has to be even as well, which means if you pick something that the difference is not even or the sum is not even, then oh the question was find an element from z cross z such that it's not in the image. Okay, any other question? I didn't find the image. I found the relation of those two numbers of image. Okay, I didn't actually find the image. I found the relation between those two numbers, so I picked something that doesn't have the relation. So you pick something first and you show that it's not in the image, like what I did here. So I picked this first, then that's gonna be x plus y equals to 0, x minus y equals to 1. Then I solve for this. This is a contradiction, so it's not in the image. Okay? Any other question? Wait, how did you get that? Let me repeat it again. I picked this element from Z cross Z. Okay, so I picked this. In order for this to be an image of your function, your x plus y has to be 0, and your x minus y has to be 1. Does that make sense? Remember, this is your image. This is not your domain. This is not your domain. I just realized you made it your domain and you subbed it in the function and found your x plus y and x minus y. This is your image. Okay, I assume that this is in the image. So this would be equal to this, not this, okay? Okay. Bounded function. Let's do a simple one. Okay, again, I mentioned before, how do we know which to pick? I found the relation between those two numbers. Well, I subtract them and I found out the difference has to be even. Or you can add them together, the sum has to be even as well. Okay, so since I know the difference has to be even, what I can do is I can just pick pairs that the difference is not even. So you can pick two pairs, for example, for this one, the difference of them is 1. So that's not even, so I know it's not in the image. Does that make sense? Same here, you can pick something such that if you add them together, it's an odd number. Okay. Image question. Let's forget about that. We did image. We'll do function. We'll do this one. Okay, we'll do this one because we don't have enough time. We did this one as well. AGM function, 20 minutes. So let's do this. So we have a function. F mapped from R to R. And f of x equals to x plus 5. The absolute value of x plus 5 over x plus 5. Is this function bounded? Justify your answer. Let me find an HM question. Why do I feel like this question is really familiar? Oh, it was on your problem set, right? Yeah, makes sense. Let's do something else now. Let's do this. Hold on, let me just change a function. Let me think of a function. 0 to infinity, 2 real number. And I want it to be, what do I want it to be? X plus 1 over x. Cool. Actually, is this good? No. Hold on, let me use another function. This goes to infinity. I want something that's actually bounded. Do I have a function that's actually bounded? Nikita, yes, you show that it's between 0 to 1. So that means that the absolute value of f of x is less than or equal to 1 for all x. So that's showing that it's bounded. Let me find another function. I'm hungry. I'm just hungry. I will eat breakfast. What do I want to do? Oh, let's do this one. 2 to infinity. F of x is x over 1 plus 2x. Okay, is this bounded? Try this and I'll find the AGM question. If you have question, you can ask, but I'll answer later, okay? Let me find another question. Oh, Daria's back. Or are you here all the time?
No, I left at like 10:30ish and I came back at 11:30.
Oh, okay. Can I find a good AGM question? You have a good AGM question?
AGM?
Yeah.
I can look. Let me see.
I'm hungry now.
Eat.
No, I don't have food right now. I'll make something after.
Order something. But
Yo, I have to attend 1 or 2 lecture from 1 to 3. I order
you can
now.
eat in class. I also have same time, 103, 102, 1 to 3, and I eat.
Yeah, I mean, if I order something, it might be too late.
Ah, okay. Do you want to do like the maximum and minimum possible value question for AGM?
Oh, true. Actually, I feel like I did a lot of that.
Okay, and let me find something else.
Actually, I don't think we have time to cover AGM. Just watch the video. I think I have a lot of AGM questions in the video. I'll post the link here and just do the questions down there, okay? Don't think we have time because I'm hungry. Oh, after this question, we are done for today, okay? I'm really starving right now. Oh, I have food from yesterday. I didn't finish what I ordered yesterday.
You didn't?
No, I didn't.
Wait, did you have breakfast or is this gonna be your first meal?
It's my first meal. So that's why I'm craving for food.
Okay, while they're doing, you go heat the food. I will ask, like, I am also here. Go heat up the
Hold on,
food.
hold on. Let me send the link to the AGM video, and Daryl will take over. Yeah, show them this question, and after this question we're done. I'll go heat the food. I don't think you can write anything. Let me make you a co-host. Okay.
Mhm. Does anyone have any answer? Is there no opinion for anyone? Awesome. Do you have a reason why? Okay, sure. We have 10 more minutes. Is it enough to show a smallest value to say a function is bounded? Is that enough? Like it's needed to show that there is a smallest value, but is that enough? Okay. Remember, you can't use calc. So if you want to show there is an asymptote, you would have to like say that in one or two terms. So think about how you would say that in one or two terms. Okay, how many of you need more time? I don't know how long it will take to do this question. Does anyone need more time? If you do, just put it in the chat. Can I take it up? No one said you need more time, so can I take it up? Okay, awesome. So yes, you're right. So it is, since it's from 2 to infinity, it does have an asymptote at half, and the smallest is 2/5. But you can't say it has an asymptote at half. So I'll show you how you would write it. But let's start with the 2/5. So first, wait, why can't I write? Okay. So we know x is bigger than 2. Okay. So that means, wait, this is not letting me write. Give me 1 second, guys. Oh, okay. Can you guys see what I'm writing? Hopefully you can. 5x minus 4. Wow. And I'll tell you why I am doing this step here. I'll tell you in a minute. 5x minus 4x is greater than 2, which means 5x is greater than 2 plus 4x. I'm going to first write it. I'll explain why I'm doing what I'm doing in a second, guys. This is bigger than 2 times 1 plus 2x. This is bigger than, so this means x by 1 plus 2x is bigger than 2 by 5. So I just cross multiplied a bunch of things. And how did I know this? So it's slightly cheating in a sense, because when I looked at the function, I knew it would be an increasing function when it's from 2 onwards. So it's just like understanding the denominator and the numerator relationship. So I knew the smallest would be at 2. So I found the value at 2. So that's the first thing. So this is the actual step you would write, the thing in blue. I'm going to write in red what went in my brain, i.e. like the rough work aspect of it. So rough work, I basically found what is f of 2, and I think I got 2 by 5. And then I realized that this function is going to keep increasing from here. And remember that 2 is not actually in your domain, but it's like everything bigger than 2. So I knew it, I had to check. So will it always be bigger than 2 by 5? So again, I found a 2, and I had like looking at the function, I knew it would be increasing from there. So I'm checking, is this actually true? And I'm basically going to do rough work. This is rough work. So I just cross multiply, I get 2 plus 4x, and that gives me x greater than 2. And I'm like, okay, this is true because my domain is x greater than 2. So that's my rough work. That's what happened in my brain. And from that, I can write the actual answer, which is in blue. That's your first part of it. Is that clear? Like how I got that aspect of it? Awesome. So once you have that, so we now got a lower bound. So when you want a function is bounded, you have to get a lower bound and you need to get an upper bound. So usually a lower bound is easier. You could have just said like, x is bigger than 2. So x is positive, 1 plus 2x is also positive. So the whole thing will be bigger than 0. That is also correct. I mean, I don't think we'll penalize you for that because you found a lower bound, which is 0. But the actual best lower bound is 2 over 5. Okay, but the upper bound is a bit trickier. So there is an asymptote at half, and again, so that I realized that by looking at so you have to have an idea about the functions and what it does, and how, like when I was in first year, when I had no idea how functions work, how I found this out is I plugged in values. I mean, you like depending on the time and how much you are comfortable with functions, you can decide how many functions values you want to plug in. So basically, I just plug in what is f of 2, what is f of 3, f of 4. Like a few values when I plug in, I start seeing a pattern in case you have zero clue like what the function actually will look like. But if you're very familiar with functions, their properties and stuff, you can look at this function and you kind of realize. Also, I mean, you can actually use calc in your rough work. Like nobody is going to stop you from using calc in your rough work. So if you use calc in your rough work, you'll see that when x gets bigger, f of x is approaching half. The second you know it's approaching half, just getting the half value again, you can either use calc, you can use your intuition, or you can plug in values and notice patterns. Whichever method is comfortable, use that for your rough work. once you get it as half, you just basically check, how do I show it as half? So this is my rough work. It means 2x is less than 1 plus 2x, which basically says 0 is less than 1. And we know it's right. Like that's something we already know. So now your actual proof, you'll start by saying 1 is bigger than 0. So 2x plus 1 is bigger than 2x. And that means, okay, what step did I do? Yeah, cross multiply. So x by 1 plus 2x is less than half. So that's your second inequality. So overall, you get x plus 1 by 2x is between 2/5 and half. It's less than half. And x plus 1 by 2x. Sorry, guys. X by 1 plus 2x is bigger than 2 by 5. But remember, to show a function is bounded, you basically need to show that it's between it's like this, an absolute value of f is less than or equal to m. So you basically want to get f is between minus m and m. That's what you basically want. I mean, less than or equal, or yeah, less than or equal. Yes, you can use this instead of, wait, can you do this using triangle inequality? If you can, wow, I'm dumb. If that was easier, but I would have done it this way. So finally, combining these both, you can just say, like, if it's bigger than 2/5, it's also bigger than minus half. That's just, you guys can see. So this is between minus half and half. This is supposed to be minus. I don't know why it looks like an Z. So you basically got that your function is between minus half and half. And why am I writing minus half? So I can write it in this form. That's the only reason I introduced minus half here. I mean, it's bigger than 2/5 means it's bigger than minus half. So your final conclusion will be, yes, it is bounded because it's in satisfying this property. Now, if they ask you to find m, that's a whole different thing. Remember that we don't have less than or equal to here. We only got less than. So your m is not really half because you don't attain half. Like if you compare with this. So you know what? I'll just change it to this. This is what we found right now. And so your function is basically bounded because it's between minus half and half. Or in other words, the absolute value of the function will always be less than half, so it is bounded. So again, reiterating, to show that a function is bounded, you basically have to find a lower bound and an upper bound. And to find those, you're allowed to use any method you want in your rough work. If you think calc helps in your rough work, go ahead. But in your actual proof, which is the stuff that I wrote in blue, you're not allowed to use calc. So the steps you have to write, once you get your bounds using calc, using patterns, whichever method you think works best for you, once you get the bound, you just do rough work on, reverse the opposite side of the inequality, just do it, and then reverse the steps to get the actual proof for the question. Ling, are you here? Ling?
Yeah, I'm back.
Do you want to add something? Is there something I missed? I literally just did it right now. I have no idea if I missed anything.
Actually, there is another way.
Yeah, I feel like that is an easier way.
1/2. Yeah, for 1/2, there is another way. So let me just write it. Where do I want to write it?
How did I get x by 1/2?
I'll write it here. It's short.
Okay, so Ling will show you a method how to get that, how I got it. So there are many methods. One is if you know calc, if you already know calc, you can just do the asymptote method. Again, remember in your rough work, you're allowed to use that because it's your rough work. It's not your actual proof. That's how I know it will be less than half, one method. Second method, if I know nothing about functions, I basically plug in some values, f of 2, f of 3, all this kind of stuff, and I notice a pattern to get the number 1/2. But in this question, you can also do what Ling basically did. Again, which method works best for you is different for different people. If you see like what Ling wrote in green right now, it's probably like the easiest and simplest method. but some people don't see it, and that's fine. If you don't see it, and if you are very comfortable with calc, getting the 1/2 values, you can do it with pure calc. But once you get the value, the proof itself shouldn't be calc. That's the only thing. So
Yes.
getting the amount itself, do it any way you want. We don't care. But prove the thing using, don't use calc when you actually do the proof.
Yeah, so we don't care how you got the actual bound. But when you prove it, don't use calc. Your rough work, nobody's gonna check your rough work. Oh, also another thing is, I noticed that some people wrote their actual proof under rough work, and that's really hard for us because we don't mark your rough work, and I can see clearly your proof under rough work is correct, and I actually struggled to decide if I should give you a mark or not. So if your proof is an actual proof, then don't write it under rough work. Okay, your rough work is like, we don't care about your rough work. Is there anything else you want to add? Oh, for AGM, no, for inequality questions, if they ask you to find maximum or minimum value, make sure you check if it's the actual maximum or minimum. We talked about that. And what else? Oh, don't start with what you need to prove. Really important. Also, I feel like they might give you even odd function for contrapositive or contradiction. So, if that's true, then when you write even number as 2k or odd number as 2k plus 1, make sure you define your k. Okay, make sure whatever variables you introduce, you always define it. So you need to let me know if the k is natural number, if it's integer, if it's real number. Also, if you want to use anything that's not proved in lecture or course notes, please prove it. Otherwise, you cannot use it, such as set identities. If the question specifically said no set identity, then you don't use it. Also, if the question said use contradiction, then you have to use contradiction. If you use contrapositive, even if your whole proof is correct, we don't give you a mark. Okay, if they ask you to use something, then you use that. You stick with that method. I don't know what else. What else you have to mention?
Okay, I want to mention something not specific to the content, but logistics aspect. So you're getting 1.5 hours, which usually the term test is 1 hour. So we're giving 1.5 hours. The half an hour is for your uploading, like taking the picture, scanning, anything that of that sort. So please make sure you're not waiting till like 1 hour 26 minutes. You're writing till then, and then you're trying to like upload and all that. That is not going to be accepted because the half an hour is given just for that. You're supposed to finish the exam in 1 hour. So please make sure, like, if you're not done, that like, let's say you're like, you have 10 minutes left or something and you're still not done, upload what you have. That's more important. Like, whatever you have to make sure it's uploaded on time. Anyways, that was just a
Oh,
logic.
also another thing is, like, I think CloudMark can track exact time you uploaded each question. So once you finish the question, you upload it. Finish another question, you upload it. In that case, even if you are late, you might get some of the question submitted while the other question is not submitted, but that's better than nothing, right? I think that's it. Oh, another thing is, whatever you used, you have to tell us you used it. So for example, you used AGM, then you say by AGM. You used inductive hypothesis, then you say by inductive hypothesis. Also, some common mistake. What's common mistake? The empty set and the set of the empty set. Remember we talked about that. Also, if you are asking to draw the sets, make sure if you don't include that specific point, then use the empty circle to label it. Make sure you label those if you're asking to draw something. I think that's everything. Yeah, I think that's everything. If you get stuck, write down definitions. Sometimes it helps, okay? Write down definition. I'm not saying you'll get marked for writing definition, but write down the definitions usually helps you to
I mean, you might even get marks depending on the
you
grade,
might get marks.
but not too much. It's better than nothing.
But write down definition definitely helps, especially for this course, because most of the questions are just definition unwinding. Yeah, I think that's everything. Bye everyone. Good luck on the test.
Good luck on the test. Yeah.
Okay. Bye.